There is no. Oh, in here, this one?
Yeah, is there one in there?
Oh yeah, Gemini, an end and a beginning. 28 minutes.
So this is a Gemini film that I found in Wisconsin that I can't find any record of, and it was like Gulf Shell or Gulf Oil Corporation. My projector is being a little bit slow. The grease is it's speeding up.
Well, when we first started it was really flashy.
Yeah.
But she's moving along pretty good.
I haven't run it in 4 years, and so it just needs to run a little bit for the grease to get around. But let's play it.
Is that thing on?
Oh, fuck off.
Is it?
Fuck off. You asshole.
Oh, look at that flickery.
Yeah, it's
flickeriness. Boy, it's bright.
Yeah. Is it too bright?
Yeah. No, not really.
I wouldn't worry so much.
The installation of the film.
I have to make sure that the film hugs the audio head, right? Otherwise it won't have clear audio. It gets all gerbled. Gerbled. Oh, we already got one splice in here. Got a bunch of splices of. I think this film was $5, something like that.
And you got the gonculator mechanism adjusted? Ooh.
Now, why are you going? This is why you use a film later.
Yeah, because doesn't the back wheel like provide tension and?
Sorry, man. This sprocket just isn't gripping. I really need to put new oil in this thing because it's like so slow. The audio is probably gonna be like, you know. Oh well, we'll see what happens.
We're engaged. Oh, there it is.
This is a view of the Earth as seen by astronauts returning from space. A sight only a few men have been privileged to see. Gemini. An end and a beginning. A summary of the NBC News television coverage of the Gemini program. As produced for the Gulf Oil Corporation.
That's not so bad.
No two flights were exactly the same, except at the end. The welcome, comforting report that always came back from the recovery ship. They're down, they're safe. All is well with the men of Gemini. Virgil Gus Grissom, command pilot on the first manned mission, March 1965. One of the original 7 Mercury astronauts. James McDivitt and Edward White. White, the first American spacewalker. Gemini produced a new breed of astronaut. Broader academic background. Less emphasis on test pilot experience. Gordon Cooper and Charles Pete Conrad. Like the rest, bearing the mark of a new breed of adventurer, but not freewheeling or gung-ho. Performances were businesslike. Walter Schirra and Thomas Stafford showed what skilled pilots could do with precision and accuracy in achieving the first orbital rendezvous. Frank Borman and James Lovell, the Gemini 7 crew. They proved man could live and work and endure in space for as long as 2 weeks, a period far longer than necessary for a round trip to the moon. Neil Armstrong and David Scott. Theirs was a life or death drama. Their capsule tumbled out of control. They showed man could pilot a spacecraft in an emergency, even when automated systems could not. Stafford was the first to fly 2 Gemini missions. Eugene Cernan, our second spacewalker. More than 2 hours outside this time, Gemini 10 pilots John Young and Michael Collins. Like those before, they had spent more than 6 months in training, 50 hours a week, preparations exact for a single flight. Charles Conrad again, and Richard Gordon. They attained rendezvous during first orbit. They journeyed farther from Earth than man had ever gone before. The final mission, James Lovell and Edward Aldrin, November 1966. 16 astronauts flying 1,933 hours, around the world for 80 days, 608 times. I'm Frank McGee, NBC News. Mercury was the first, and Gemini, the intermediate, can only be learned in space. The skills of maneuvering, of rendezvousing and docking, and making precise landings on Earth from orbit. Astronauts have knowledge about everything from the freezing temperatures of cryogenics to the broiling heat of the lighted surface of the moon. Hundreds of lectures, thousands of documents to read, uncounted hours of homework, simulations, and physical conditioning. But with almost irresistible momentum, the United States put up a new Gemini shot every 6 to 8 weeks. Gemini's challenge to the state-of-the-art manned flight began with the capsule itself. The two-man Gemini spacecraft was more advanced, complex, and versatile than its one-man predecessor used in Mercury. It weighed 6,900 pounds and was a little over 18 feet long. From a 39-inch diameter cabin tip, it widened to a 10-foot diameter at the base. Above each astronaut in the pressurized cabin was a hatch, large enough to allow normal entry and exit or emergency ejection. The Gemini was designed to be navigated by the astronauts in flight. Its basic construction material was titanium. It was divided into 3 sections: re-entry, or the cabin; retrograde, the section which initiated the flight back to Earth; and the equipment adapter. The retrograde and equipment sections were jettisoned before re-entry. In the nose section were parachutes to ease the craft down, and around the cabin base ran a heavy heat shield for re-entry. In the adapter section were many of the experiments carried out on the 10 flights. All of the Gemini spacecraft were launched from Cape Kennedy's Pad 19, which stands 200 feet from the Atlantic Ocean. It's a 3-story concrete and steel base topped by a 138-foot-high erector. Alongside is a 102-foot umbilical tower. The booster for Gemini was the Titan II, a 2-stage liquid fuel rocket which measured 10 feet in diameter and stood 90 feet high when erected. Its weight, 150 tons. The launch vehicle was a modification of the Titan II intercontinental ballistic missile. Changes were made for greater reliability and safety in manned spaceflight. Backup flight control, electrical and hydraulic systems were installed. On the second stage, a new forward skirt was fitted to allow it to join with a spacecraft rather than an atomic warhead. The launches were spectacular. Those who watched from the beaches joined millions who watched on television around the world. Spewing orange clouds of flame and white vapor, the Gemini-Titan combination thundered toward space only seconds after ignition. The Stage 1 engines developed 430,000 pounds of thrust to lift the 163 tons of joined vehicles into space and to start Gemini into orbit. A manned space mission doesn't just happen. There were months of preparations, agonizing hours of training and bookwork. The astronauts started working with their spacecraft while it was still at the manufacturers, about 6 months before the flight. And they were there for every important test and checkout. Each Gemini flight was different. The main tool the astronauts used for learning and practicing was the mission simulator. On this strange-looking device, they were able to try most everything that was scheduled on the flight, all, of course, in normal Earth gravity instead of the weightlessness of space. In order to get the real sensation of spaceflight, they had to board a special airplane. Even then, the weightlessness could only be sustained for about 30 seconds, as the airplane flew a steep parabola, resembling a roller coaster. A pilot getting ready for a spacewalk often spent several days aboard the airplane, flying hundreds of weightless parabolas. Each phase of the spacewalk was practiced separately, each technique and movement tried in the way it was supposed to be done in space. To practice an entire spacewalk, underwater training was developed late in the program. Here the astronaut Gemini 12 pilot Edwin Aldrin, in this case, could work his way through a series of actions, sometimes up to an hour in length. At the opposite extreme in the training were meetings, not as interesting, but equally important. As the flight time drew nearer, both spacecraft and astronauts arrived at Cape Kennedy. Each item had to be perfect, had to weigh the right amount. A critical test was called weights and balances. In this, the astronaut was fitted into his seat, and the center of gravity was established. Flight crews involved in rendezvous missions spent a great deal of time in what was called the rendezvous and docking trainer. Here they could actually fly the final seconds of rendezvous and then dock with an Agena target vehicle, all of it on the ground in Houston. Perhaps the least popular training, but certainly necessary, was water egress practice in the Gulf of Mexico. Crew after crew took their turn at getting wet. But at the conclusion, each astronaut knew what he should do in the event trouble developed after the spacecraft had re-entered and was on the water. An astronaut assigned to a flight had 3 spacesuits, 2 for training and 1 for the mission. When it came to liftoff day, the only one that counted was the flight suit. All the training was finished. The mission was ready to start. After suit up, the short trip to pad 19. Then the last handshakes and best wishes from the men at the pad. The astronauts, always together as a team, each one carrying a portable oxygen supply designed to last until they reached the spacecraft. Up the elevator, 100 feet to the waiting Gemini, about 2 hours before launch. Within 600 feet of the pad, a massive igloo-shaped concrete and steel blockhouse protected engineers and technicians who supervised every phase of the launch operations. Shielded from the violent buildup of ignition noise and vibration, these men checked the countdown second by second, right up to liftoff, always ready to handle an emergency. Keyed into the Cape blockhouse were other control installations, including the ultimate take charge by Mission Control at the Manned Spacecraft Center in Houston. Once liftoff was achieved, flight directors monitored the spacecraft throughout the entire mission. Here were ground guidance, the medical charting of the 2 men in flight, the expertise. For every Gemini flight, starting with GT4, there were 3 shifts working here around the clock, controlling communications with the astronauts, checking the actual mission against the flight plan. The nerve center, the decision makers were in Houston, locked into the flight by shortwave radio and by tracking stations around the Earth. The job of the tracking stations was to listen to the astronauts flying over their areas, acquire data, and relaying this information to Houston, a worldwide network of instant contact with every Gemini mission. In the case of a troubled flight, and this was so on Gemini 8, which had to come down in the West Pacific, these stations played their vital role. No guesswork, advanced planning that worked. As one flight director said, it was no happenstance that recovery forces were ready in the West Pacific. He and his crew had anticipated any contingency that might develop. The Gemini series went out of numerical order after the Agena target vehicle for Flight 6 failed to reach orbit. It was then decided to fire Gemini 7 first and use it as a target for Gemini 6. But there was more trouble when Gemini 6, Schirra and Stafford, the crew, shut itself down on the pad. A tail plug had come loose too soon. 24 hours later, they made it and went on to success. Later on, the Gemini project had more problems, more launch trouble. The Agena on the GT9 blew up 2 minutes after liftoff because of an engine misfire. The Atlas booster had turned on its axis instead of flying straight ahead, causing the rocket to veer over and return like a ball of fire into the atmosphere. For Command Pilot Stafford, he was Schirra's pilot on GT6, this was another frustration. What was the astronauts' reaction to last-minute postponements? Stafford put it this way.
Well, having experienced that twice, you feel rather let down because you're all keyed up ready for the launch, and you know you're trained to the nth degree, and so you just have a slight let-down feeling at the time.
10, 2, 3, 4, 5, 6, 7, 8, 9, 10.
A dozen times in less than 2 years, Titan II successfully boosted a Gemini capsule into space. In 1 second, 2 small rocket motors had started the first stage engines. In less than another second, thrust was building up and the launch was begun. The first stage engines developed enough power to wheel 9,000 Cadillacs, or to lift 215 tons into space. About 40 miles up and 45 miles downrange, the first stage began to run out of fuel. As thrust diminished, an electrical signal automatically shut down the first stage and activated the second stage engine. The astronauts and ground stations did not control these events. As the second stage took over, explosive bolts blew to separate the burned-out first stage, a maneuver you see here, filmed with an Air Force telephoto lens. The second stage engines propelled the Gemini to a height of 100 miles, as illustrated in this animated film. The thrusters of the equipment section drove the spacecraft away from the dead second stage. Powerless, the booster fell. The spacecraft and its equipment section moved into the described Earth orbit for the flight. In orbit, the astronauts photographed the most remarkable views ever made of Earth. They provided new lessons in geography, showing land masses and oceans in new perspective. Some pictures were taken as high as 850 miles above the Earth. The pictures showed erosion patterns, rock types, mineral patterns, and ocean currents. And the astronauts themselves concurred on one thing. It was the most beautiful sight they had ever seen. After 6 successful Gemini Rendezvous missions, there was little doubt that American astronauts had mastered the technique which is to be so vital in the nation's plans to reach the moon. But the first few times the maneuvers were attempted, there was no certainty they would work. In fact, there was real tension. NBC News explained the extremely complex maneuvers with a simple set of electric trains. The space train showed how the Gemini pilots changed their orbits through a series of maneuvers with the spacecraft rocket engines until they were in the same orbit as the Agena target. Once Rendezvous was completed, there was generally a short period of station keeping before the spacecraft moved in to dock. In actual practice, the Rendezvous turned out to be a bit easier than anticipated, but still a challenge for each command pilot. There was something incredible about the idea of 2 different machines, each going more than 17,000 miles an hour, being able to meet in the vastness of space and fly at the same speed. Docking itself was no problem. Here was the way it sounded on the successful Gemini 11 docking with astronaut Charles Conrad at the controls.
Roger, you go for docking.
The most frightening moment in the whole program for those on Earth, and probably for the astronauts as well, came on Gemini 8 just after docking. The crew made a safe, emergency landing in the Pacific Ocean. Another disappointment came on Gemini 9 when docking was impossible because the shroud did not come off the target vehicle. Command pilot Thomas Stafford described it this way.
How are you? I've got a weird-looking machine here. What does it look like? Okay, both the clamshell of the nose cone are still on, but you're open to watch. The front release says, let go. It looks like an angry alligator out here rotating around.
But the Agena target vehicle used in rendezvous missions achieved quite a record. Among other things, its large engine was able to carry astronauts aboard Gemini 10 and 11 to record-breaking altitudes. The Agena engine lit up the entire sky. At high altitude, the view was breathtaking. The astronauts could see the Earth as a sphere. From one horizon to the other, the view stretched across 4,000 miles. The Gemini 11 crew could see from India to the Pacific Ocean. The astronauts, of course, were not sent up just for the view. The unprecedented climbs provided valuable information about propulsion in space, as well as new data on radiation and geology. An experiment devised late in the program was called Tether Exercise. The idea was for the Gemini and Agena to be attached together by a cord or tether. Then the Gemini would pull away from the target up to the full length of the tether, about 100 feet. Then they were supposed to study what effect this had on the two vehicles. At one point, the crew was instructed to turn the vehicles into a spin. Another time, they maneuvered the craft to where the Agena was pointing directly toward the Earth. As in all space experiments, new information was learned, this time about how two objects in space could function together with the saving of fuel. On Gemini 4, Edward White made one of the greatest contributions to America's history of space exploration with the first walk in space. The Russians had done it first, but White did a more sophisticated job. With the help of a little maneuvering jet gun, he stayed out for 21 minutes and had to be ordered back in. The command pilot, James McDivitt, kept up a running dialogue with White, and so did the ground.
This is the greatest experience I've just remembered. Where are we over now, Skip? I don't know. We're coming over to Washington. They want you to come back in now. Back in? Back in.
The flight director says get back in.
Jim, got any message for us?
Jimmy Fuller, get back in.
Although it looked rather easy when White did it, extravehicular activity proved to be otherwise. Eugene Cernan went out on Gemini 9 and worked so hard he overheated his suit. Richard Gordon on Gemini 10, even with handrails suggested by Cernan, was overcome by fatigue.
I'm here, I guess. Sure are. Right up, Jumbo. Let's just sit here and take a rest. How you doing? Tired, Pete. All right, just rest.
But the problem apparently was solved by Edwin Buzz Aldrin on Gemini 12, thanks to better handrails and tethers, effective foot restraints, plus the benefits of extensive underwater training. After the flight, Aldrin said the underwater training gave him the experience of continuity while working during EVA. This was not possible in KC-135 training because the airplane gave him weightlessness only for periods of about 30 seconds. Aldrin completed practically every task that had been assigned to him. And on top of that, he set a new duration EVA record, a total of 5.5 hours during 3 separate excursions outside the spacecraft. Only the Gemini spacecraft and its crew returned to Earth. The equipment section, its work done, was dumped in space. Then the retro section, designed to kick the spacecraft out of orbit, fired its rockets as illustrated in this animation. The trip home had begun. The spacecraft was positioned by the astronauts with the blunt end forward to absorb the dynamic stresses of...
Got a problem with the filming.
Oh,
It stopped turning.
oh, you're off the reel.
Yeah, that's fine. That's great.
Yeah, delicate city.
I've done this before, though. It's not too bad. Okay, so At least it's speeding up and keeping a nice speed on the projector now.
It looks good.
Yeah. And this is color. It's just that it's so degraded, all the other inks have gone out. So I might be able to, with my digitizer, I might be able to bring out some of that color.
Like in between some of the shots, it's just red.
Yeah.
But yeah, is that because of the degradation of it?
The red dye is the only one that really lasts this long.
Oh, okay.
Yeah.
The dish-shaped heat shield was made of special ablative compounds which made it 125 pounds lighter than the old Mercury capsule shield, but still totally effective. Wrapped in a heat envelope, the spacecraft hurtled toward Earth. Plunging into the Earth's atmosphere, the spacecraft underwent a brief blackout of radio communications with ground stations. This film was made aboard the spacecraft as Gemini 12 returned to Earth. Aerodynamic drag slowed the Gemini to near sonic speed, less than 600 miles an hour. At about 60,000 feet, a drogue chute slowed and stabilized the spacecraft as it descended. At 10,000 feet, a ring sail parachute slowed, then eased the Gemini into a water landing. Automatically controlled, the last of the Gemini flights splashed down very close to recovery ships and in full view of millions of television spectators. With the help of frogmen, the astronauts and their spacecraft were quickly brought aboard recovery ships. Then what became a Navy tradition, the welcome for the astronauts. At the end, many of the problems that had loomed so large at the beginning were forgotten. There had been high achievements and some disappointments, but the United States now had a tested worldwide tracking and control network. It had a pool of experienced astronauts. They had mastered orbital flight techniques, rendezvous and docking, making large orbital changes with an attached vehicle. Launch crews had learned how to send 2 spacecraft into orbit on a critical time schedule. Industrial know-how was at a new peak. Our astronauts had accumulated more experience with weightlessness than anyone. The only original goal not achieved in the program had been development of a method to land on ground as well as in the water. And so we entered the climactic Apollo venture with justifiable confidence. There was no assurance that we would be the first to make the lunar voyage, but the foundation had been laid. The drama at Pad 19 was over. We had been conditioned by a long series of successful space missions and a perfect safety record. It was a false sense of security, for no major exploratory program has ever been carried out without some loss of life. But across the Banana River toward Merritt Island and Pad 39, where someday 3 men will climb aboard a rocket and roar off toward the moon, death came. The first Apollo astronauts perished during a ground test in their spacecraft. But the great experiment will go on. There are 80,000 acres of moonport at the John F. Kennedy Space Center, and this is the Vertical Assembly Building, an unglamorous name but challenging to the imagination, where moon rockets will be assembled, stored, and then hauled out as needed. The rocket itself, the most awesome, complex engineering and construction job yet undertaken by man. 364 feet high, the equivalent of a 36-story building. Weight, 3,000 tons. Generating a thrust of 8,700,000 pounds in its 3 stages. 16 times more powerful than the Titan II of Gemini. Astronauts will first practice in Earth orbit. The rocket will be launched without men. Then the spacecraft will be launched unmanned into orbit and tested. Eventually, it will carry men to the moon. A mere decade ago, we lifted our eyes and could only call this undertaking fantastic. The most daring adventure ever conceived. Silent, dead, airless, the moon. Someday, perhaps, to yield not only secrets of the Earth's origin and of the solar system, but offer a brilliant new view of the universe, unblurred by atmosphere or man's inadequacies.
By clapping.
Well, I didn't know I wasn't supposed to say anything.
I'll get a better recording later. So this is what I had. So this is what I had to deal with. Didn't have a big enough take-up reel, and so I was having to go like this and like squeeze it in, and then adjust the focus, and adjust the focus.
That's got the big lead on the end.
Yeah.
Just not on the other end.
I like this whenever it starts really going. I have this one reel, it's like a big one, and it goes down to like that small, and that thing really gets going. It's one of those like super long ones though, so they had to squeeze out as much as they could.
I remember back in school when the teacher would like forget to, she wouldn't be standing there after it got done, and it was like, whap, 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 whap.
Yeah.